All right, so yesterday we talked about 4.3, the ways to classify a triangle by its side lengths and its angles. So what are the ways to classify by a side length? Isosceles means at least two sides the same, right? What's another way to classify a triangle by its sides? Equilateral, which means all three sides are the same. Scalene, which means no two sides are the same. Okay. How about by its angles?
Equiangular.
Equiangular, which means all of them are equal to each other. Obtuse, which means one angle is more than 90. Right, which means one angle is right. And then acute, which means all of them are less than 90. Okay, that's what we talked about yesterday. So if we're doing 1, 2, and 3 to classify the triangle by its angles and its sides, the first one is MNQ, which is here, this triangle here. Okay, so I don't know anything yet about the angles. Okay, but I do know what's true about all three sides. They are the same, which means equilateral. Okay, if I look at this, okay, if you look at that diagram that's given to you, there are some clues that you have. What's true about these two angles here? They're a linear pair, and then what's true about a linear pair? They're supplementary. So if one of those is 120, what's the other one? 60 degrees. Everybody with me so far? Yes. Okay. Another way you could look at this is that if all three, which we're going to learn a little bit, if all three side lengths are the same, what do we think is going to be true about all three angles? They're going to be the same. And if they're all 60, what's true about that triangle classified by its angles? Equiangular or? Yeah, technically, but by angles, what else would it be? Acute. So sometimes we can state more than one thing.
Would it be wrong if you just put one of them?
No. Unless it says to list all. Okay, second one is NQP. So NQP is this triangle on the right. So first, look at its sides. What do we know about all the sides? Let's look at the sides first. One is 6, one is 8.1, one is 3.2. What's that tell you? Scalene. And now look at the angles. One's 20, one's 40, one's 120. What does that tell you? Good, obtuse. And then the last triangle, MNP. MNP is my big triangle. So we said that this was 60 in here. We said that this would be 60, so now I know this top angle would be 80. And then this right one is 40. So if I have, let's start with the sides. One side is 8.1, one side is 6, and one side is 9.2. Scalene. The sides, this one is here, 8.1. This one is here, 6. And then this one has both the 6 and the 3.2. So it's 9.2. And now look at the angles. I've got my 60 degrees, 80 degrees, and 40 degrees. What does that tell you? Acute. Good. All right, number 4 says find the side lengths of the triangle. So what kind of triangle is this? Isosceles, which tells you that these two are the same. 3x plus 2 equals 4x minus 7, and then solve for x. So subtract the 3x. Add the 7. X is 9. But again, be careful because it's not asking for x, right? What is it asking for? The lengths of the sides. So what do I have to do with that 9? Plug it back in. So for these, it shouldn't matter which one you plug it back into. They should be the same, right? Because they're isosceles. So 3 times 9 plus 2 would be 27 plus 2, or 29. That's this side length. If you'd want to check it here, This is 4 times 9, which is 36, minus 7, which is also 29, so it works. And then the one on the bottom, I'd plug it in there. 2 times 9 plus 5 is 18 plus 5, or 23. So the 3 side lengths are 29, 29, and 23. All right, again, so those are the answers for the homework. Okay, so we're going to start 4-3 today. We won't do it all. Okay, but we're going to start it today. And then we'll finish it. Again, I'm not here tomorrow. I am leaving an in-class assignment for you. What does that mean? It's due at the end of the class period. I wrote it in the instructions, but should Canvas crash, what could you do? Email me before the end of the class period with your file and your reason why it's not working. Okay? No excuses this time, folks. So, and then we'll finish 4-3 on Thursday, review on Monday, quiz on Tuesday. So 4-3 is called angle relationships in triangles. So now we're talking about the triangles and all the things that happen to the angles on the inside or the outside of a triangle. First one, again, get to feel super smart because this is stuff you already know. The triangle sum theorem says the sum of the angles of a triangle add up to 180 degrees. So in this triangle, angle A plus angle B plus angle C would equal 180 degrees. That's called the triangle sum theorem. So it has a name. All right, an auxiliary line. So this is just a vocab term that helps you determine like what goes on from here. An auxiliary line is a line that's added to a figure to aid in a proof. So sometimes we have to add stuff in order to figure the rest of the stuff out. And all this is saying that if I added a line to this diagram, so this would be my auxiliary line, then what I know about these 3 angles is they would be what? They would add up to 180. Now, if you think about what you know about parallel lines and special angles, what's true about 4 and 1? Alternate interior. And if those lines are parallel, what's true about alternate interior angles? They're congruent. Good. How about 5 and 3? They're also alternate interior angles. And what's true about alternate interior angles? They're congruent. So this is where the proof gets proven. Okay, that's all. You're not going to be tested on this. That's just an explanation of where it comes from.
You can make more transversals if you need to.
Sure.
Really?
Yeah, as long as those lines are parallel, you can set up all the relationships you already know. So everything that applies about a linear pair would still apply, and everything that applies about alternate interior would still apply. But again, I won't, like, that's not something you need to be able to decipher or explain. That's just where that proof comes from. You just need to know they go 180. All right, so example 1 says, after an accident, the positions of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collected to find the measure of angle X, Y, Z. So a whole bunch of words that freak you out for no reason because all you're looking for here is angle X, Y, Z. How do I find it? Ryan.
You add up 62 and 40 and then subtract that 180.
Exactly. So this would be 102. That's the sum of those two angles. And then I would do 180 minus 102. And I get 78 degrees.
Subtract that by 12, right?
No, the 12 is on the outside. So if I was looking for the whole angle, I'd actually have to add 12 to 78. But the 12 is this little sliver here. So it's really in there. It's totally extra information I didn't even need. What kind of triangle would this be? Scalene and?
Obtuse.
Nope.
Acute.
Acute. Good.
How do you get 78?
Okay, example 2 says use the diagram to find the measure of angle MJK. So MJK is this angle here. So there's 3 triangles going on there, right? This is one of them. And from that triangle, I know one of the 3 angles but I need some additional information. What could I do? Braylon.
Alright, it's showing that angle M and angle K are alternate interior.
So they're not alternate interior, and the only reason is because you don't know that those lines are parallel. But what is marked is that they're congruent. So they don't have to be alternate interior to be congruent, right? Those are marked as congruent. Those little red arcs tell you those two are congruent, right? That's that's on the track that you're on.
Yeah.
So how does that help you?
Isn't M and K congruent, like the same?
The two angles?
Yeah.
Mm-hmm.
So that'll make angle K. Angle K 48, which will make angle M 48.
Oh, wait. This one's not the same as this one.
Couldn't you do 88 plus 48 minus 180?
Yes. So I'm going to first use this triangle to find the missing angle, right? So I would do 88 plus 48, 136, and then subtract that from 180. And that's this top angle. Everybody with me so far? So now if that's the top angle and these two are congruent, then this one is also 44. And now do I have enough information to get JKM?
Yes.
How?
Because since they're congruent and the same, so 104 plus 44, and then you find that answer.
Good.
And you subtract by 180.
Perfect. So 180 minus the 148. And I get 32. That's what angle KJM is. So sometimes you got to do a little work to get there and combine all the stuff that you already know to do it. So this describes your angle, right? MJK. The J in the middle is your vertex. So that is why we went M to J to K, and that's how you know that that's that angle.
So when they have like the 3 letters.
So if it's 3 letters, the middle one is the vertex. And if a letter is shared by more than one angle, that's why that J is like that. So like if I said just angle J, how do you know which J I'm talking about, right? Am I talking about the 70 or am I talking about the 32? That's why you have to have, so this we found was 32. If I just said angle J, you couldn't tell me if I'm talking about the 70 portion of J or the 32, and that's why you need 3 letters. So N can be called N because that is no other angle that is sharing N. L can be called L because no other angle is sharing L. But every other letter there, if I wanted to describe an angle, I had to use 3 letters because they are shared by other vertices. Does that make sense? Okay.
So how do you?
So let's say I was naming the 104. How would you name that? JKM or MKJ. Does that make sense? The middle one is your vertex. How would I name the 88? KMN or NMK. Good. So careful with the letters. All right, a corollary is just a theorem whose proof follows directly from another theorem. So this is something that's easily determined from another theorem. So in this section, there are 2 theorems that they think if you knew something before this, which is the information we just talked about, then it's easy to determine these next theorems. And the first one is the acute angles of a right triangle are complementary. What does acute mean? Less than 90. So if I look at the little triangle that's there, which is definitely a right triangle, there's a right angle there. What are my acute angles? D and E. What do I know about all 3 angles? What do they sum to, all 3 angles? 180. So if one of them is 90, what's that leave the other 2 to sum to? What's 180 minus 90?
90.
So 2 angles that sum to 90 are called what? Oh, so close. Complementary. Okay? So you just proved that theorem based on what you already knew. You knew that all three angles in a triangle add up to 180. You knew that in a right triangle, one of them is a right angle. So if I subtracted that 90 degrees, the other two have to add up to 90 degrees. And two angles that add up to 90 degrees are called complementary. So that's all this corollary says. The acute angles of a right triangle are complementary. And then the second one says the measures of each angle of an equiangular triangle is 60 degrees. So again, what do we know about all three angles in a triangle? They add up to 180. And if it's equiangular, what's true about all three angles? They're all the same. So if I take 180 and divide it into 3, I get 60, 60, and 60. Okay? So again, these are things that, what this means is basically these should be easily understood based on what you already know. So the acute angles of a right triangle are complementary, and the measures of each angle of an equiangular triangle are 60 degrees. All right, example 3 says one of the acute angles in a right triangle, and that should be a measures, 2x. What's the measure of the other acute angle? So if you need a visual, give yourself a visual. If not, you can just use that corollary. So it says that one of the acute angles of a triangle is 2x.
So that angle is 2.
So we don't know what it is. We just know it's 2x. So it's like you're going to keep a variable in your answer because we don't know exactly what it is yet, right? But what do I know about these two angles? They have to add up to 90 degrees, which means 2x plus whatever angle this is. So let's add in a variable like y. Equals 90 degrees. So if it's saying what's the measure of the other acute angle, it's 90 minus 2x. So the two angles together add up to 90 degrees. If they gave you a number, like if they said one of them was 30 degrees, then I would just do 90 minus 30 to get the 60 degrees. But if you don't know what the value is, in this case it's 2x, then to get the missing angle, it would be 90 minus 2x. Okay, this one says the measures of one of the acute angles in a right triangle is 63.7 degrees. What's the measure of the other acute angle? Again, if you want the visual, draw it out, but hopefully you don't need it every time. So if this is a right triangle and one of them is 63.7 degrees, how do I find the other one? Subtract it from 90. So 90 minus 63.7. I need the placeholder, so 90.0 minus 63.7, make that 10, borrow again, so this is 3, 6, 2, or 26.3 degrees. These should be easy to check because if I add these two back up, I should get 90 degrees. Questions so far? Okay, the measure of one of the acute angles in a right triangle is x. What's the measure of the other acute angle? So hopefully we don't need a visual third time around. If one of them is x, what's the other one? 90 minus x. Does that make sense? Yep. So if they give you, if it's a right triangle and they give you one of the angles, then the other one is just 90 minus that angle. Questions so far?
Wait. That's all you do?
Yep. Good? Yes?